will be able to find that information in your Google app. So for anybody that wanna make part of it, please look at the Meetup details in Google app. And then I wanna welcome everybody to our amazing panel. We have here Sasha Lucconi, AI and climate leader in Hugging Face, Deval Pandai, Vice President of AI Engineering at Vector Institute, and then our moderator, Monish Gandhi, founder of Gradient Ascent Incorporated. And I will let them introduce themselves. So please, Monish, I give you the word.
Thank you. Thank you for that. Hello, everyone. Thank you for being here today with us. It's going to be a fun panel today. My name is Monish. I'm founder at Gradient Ascent AI, which is we build custom AI models primarily for tech companies to help them build features and products. So why don't we start maybe with quick intros? Deval, you want to go first?
Yeah, sure. Thanks. Thanks for being here. I know this is the last session on a Friday, so you all are really, really interested to know about like whatever we are going to talk about, I guess. The backstory is that we had changed the actual topic. Initially, I just assumed it was just going to be AI and climate, but I think we are going to talk a little bit more than that. I'm Deval. I head the AI engineering team at Vector Institute. Vector is a non-profit AI lab here in Toronto. I have worked at the intersection of energy transition, climate, and AI throughout my career. So yeah, that's me. Passing it to Sasha.
Yeah, I'm Sasha. I work at Hugging Face, so it's a platform for sharing AI models and data sets. And I wear two other hats that are not reflected here. I'm also on the board of directors of Women in Machine Learning. So we have a gender diversity crisis in AI. So women are around 15% of researchers. So Women in Machine Learning tries to help bring together women and organize workshops and mentorship and things like that to help build capacity, essentially. And I'm also one of the founding members of Climate Change AI. So this is something that I care deeply about. And it's a volunteer organization that's worldwide, and we essentially try to catalyze impactful work in terms of fighting climate change with machine learning. So if either of those two topics are of interest, feel free to talk to me after the panel.
Why don't we jump straight in there, right? Both of you kind of talked about your passion and interest in climate and energy transition. Maybe we can start with you, Sasha. Tell us about some of your experiences, interests, projects in this area.
Sure. I guess in terms of a brief life story, recent life story. Anyways, after my PhD, I applied for a lot of postdocs and didn't get any of them, and so ended up working in applied AI research, and then ended up working in finance. And then after a year of that, my brain was interested, but I realized that the things I really cared about were not reflected in my work. And so I quit my job and my big salary, and then I went to do a postdoc at Mila, which is the kind of equivalent of Vector, but in Montreal, and that's where I started working on AI and climate. And so yeah, this was like 7 years ago-ish. And since then, first I started working in terms of the positive applications of AI and climate change, and now my main focus of study is trying to understand the climate impacts of AI, so energy consumption and carbon emissions, and how to reduce them, essentially, how to make sure that AI has less.
So both the pluses and
yeah, exactly. Well, yeah,
minuses.
Essentially, I was working on the pluses, and people were like, "Well, what's the cost of the planet? Like, you're doing this kind of innovation, but like, there's a study that came out at the time. It was like training an AI model was the equivalent of like emitted as much carbon as 5 cars in their lifetimes. This was like the 2018, I think, study. And then at that point, I was like, what if each AI model I train is actually like doing that much damage to the climate? And so I started working on understanding that a little bit better.
Yeah, so for me, like energy, like growing up in a developing country like India was very interesting, because when I moved to US and to Texas of all places, what I realized that you flip a switch and light goes off, it's not a given, right? Even to this day, like there is a schedule shunting of energy, and so energy is like a scarce resource to a certain extent, and
there's blackouts and stuff.
There are blackouts. There are blackouts. When there was a blackout, I remember, like in New York, and everything came to a halt. But countries like India and a lot of other countries have actually figured out how to continue life during those blackouts, right, kind of thing. And so I was always interested in, say, energy security, and it's a very complex kind of an issue, because on one hand, you want 100% renewable, but on the other hand, if I'm in sub-Saharan Africa, and my child is on a ventilator, do I care if that energy is coming from solar or from coal? No.
And this is where ethics and sustainability intersect.
There you go, right? Fast forward, my first foray into machine learning and energy was with biofuels. And this was during my master's. I was building computational models to build more efficient small-scale biorefineries, like a tabletop biorefineries. And then that journey has continued. Currently, I'm most interested in the applied side of things, wherein how can we actually use some of these latest advancements in machine learning and AI to tackle some of the hardest challenges of decarbonizing industrial sectors, grid, material science, and so on. So yeah, that's me.
No, sounds awesome. And so when you talk about the types of opportunities that are out there, where can we use AI to help us with this climate challenge? Before we get into sort of the issues that models themselves are causing, what are the areas where AI, machine learning could really help us make things better?
So I like to see it. I mean, there's different ways of seeing it. I like seeing it on different scales. And so there's the molecular scale, which is everything, for example, designing new batteries. So lithium-ion batteries are great, but they're probably, I mean, they lose charge over time. There's all sorts of issues in terms of holding charges. And
I would say on the ethical side, also they come from the global south.
Exactly.
And so there is
conflict.
There's a huge conflict.
Yeah.
And also some of those regions are highly geopolitically unstable regions, right? And
so developing new types of batteries and machine learning is a really great way of doing that, finding new combinations of molecules, et cetera. Then on the more human-sized scale, everything when it comes to biodiversity monitoring. So there's lots of really interesting projects and companies, so everything that uses all sorts of data. For example, a common friend of ours works on a bioacoustic monitoring, so essentially putting microphones around in a rainforest and detecting deforestation, for example, and can be the same thing with detecting new bird species, detecting whatever animals and stuff like that. And then on a planetary scale, there's so much data from satellites, images, radar, LiDAR, everything. You can monitor the health of coral reefs from space. So there's all sorts of really cool challenges and tracking hurricanes across oceans and stuff like that. And that machine learning is really good for.
Deval, you
I'll just say, I was hoping that you would plug in for the climate change AI, but I think CCAI, you should all go to the website.
Yeah.
And they have actually, this happened, I think 2017 when the paper came out, has given a really good taxonomy of, okay, what are the fields within AI and machine learning and how can they map to some of the largest buckets where either you are reducing emissions or you are actually reversing the impact of emissions and biodiversity.
What we tried to do is really do the cross, right? For example, if you're interested in reinforcement learning and you want to work on, agriculture or transportation, what are the things you can do really at the nexus of those two things? And so we have all the different applications and all the different techniques, and then what you could find at the nexus of the two.
Right. I think some of the other pieces which I am kind of quite interested now, and I feel like the needle has moved quite a bit. You mentioned reinforcement learning, and so 10 years ago we were trying to deploy reinforcement learning on control systems to have better efficient process for refineries, and no one would let me do that. I think the field has moved much farther along, and so we are seeing now more applications of those things in anywhere. I think the answer to your question is everywhere, right? But then the question is, start with what is really going to move the needle in terms of addressing climate change or energy transition, and not getting stuck on this is the latest method and large language models are going to solve now everything. I think that is the wrong approach.
So fall in love with the problem, not the solution?
Yeah.
And also often AI is only a relatively small part of the solution. Often there's so many socio-technical problems, gathering data problems, figuring out what the problem is problems. And so machine learning at the end of the day it can be really impactful when it's the right type, part in the process, right? When you've gotten all those ducks in a row and you're now we can use AI, but first you need to.
And that's such a great point. We worked on a project just before COVID where we were helping airlines basically figure out what will people eat, buy and eat on flights, right? Do they want pizzas or sandwiches? So you would only load stuff on the plane that people want because, you're burning a lot of fuel to move food around from place A to place B that nobody eats. But the process challenges of actually sort of getting them to change and embrace this, even though you could sort of prove the tremendous savings that are there, there's just such a huge challenge. And so I think, how do you potentially sort of overcome things like that?
And now I know why my flight missed my vegetarian meal last time.
It's not me.
Their model predicted that there was less vegetarians than there were.
Yes. No, I do think there's one thing I'd add here is say almost any like really impactful climate solution is not just a software or just an AI solution. There is like a physical component to it, there's a hardware component to it. And so I think a lot of the models, especially in the innovation ecosystem, even with say like VCs and founders, they're so used to this SaaS model that we forget that AI is an enabling part of it. Maybe even like step changing, like innovation will happen with it, but that is again like going to be a part of the solution and not like the entire solution.
And I think that also when you talk to people who are already working in climate in different spaces, giving them some tools and kind of letting them run the show can be really great. Not like arriving being like, I'm going to solve all your problems with AI. And then so like I do a lot of also like tutorials and things like that. Just like, you can start with a classifier and see where it goes, or start with whatever and start gathering data and just like bringing them there, and then, checking in a year later and seeing where they've come, because often like it's so hard to have the domain knowledge necessary to figure out like what would be even an impactful solution in this space that you know nothing about, like cement manufacturing, right? Like you have to do so much kind of like homework before you get there that sometimes it's great to let the domain experts run the show.
So when we kind of think about, I want to kind of go back to the change management side of this, right? Because you both kind of said, look, the technology solution may be beyond software. It's not just software. There may be hardware, there may be other processes or systems that are part of it. How would someone sort of approach that, right? Because that's, now you're kind of suddenly going from the language of classifiers and data into like, convincing people to try something or buy something, or actually say, hey, this might save us and bring some efficiencies. Like, what have been maybe some angles that have worked well?
Maybe I can start. So I have like a very specific example here. What worked for us when I was back with like Shell, ironically, one of the largest polluters in the world, and I was trying to decarbonize their systems. Fun experience. But
fighting windmills.
yeah. Well, you know what? Like I don't know if people know this, but Shell is one of the largest operators of wind energy in US. Like and so they do things not enough, and again, that's a whole separate conversation. So what has really worked is we realized that having domain experts as product owners and upskilling them just enough so that they can understand the technology worked wonders, right? So we would go in and say, I'm going to do this predictive maintenance and it's going to reduce emissions by so and so percentage. No one believes you. But when an operations engineer, when a reliability engineer is saying that, it not only brings credibility to the product, but it also helps us build a better product, because I swear to God, I have met reliability engineers who could, from the noise of a compressor, could tell you what's wrong with the compressor. And so it's almost impossible to replicate that kind of intuition.
And I think that also focusing on kind of very specific parts of the problem, like it's easy to get overwhelmed when you want to, like this happens to me a lot of times at the beginning. I was like, I want to stop climate change or whatever. And then you realize that there are so many little problems that are more tractable, and also like taking the time to understand them and to kind of figure out where AI fits in, if at all. And also creating, so this is something that I really appreciate at Hugging Face is like creating like user interfaces and tools around AI models is actually really powerful, especially for people who can't code, and a lot of people can't, and that's fair, right? And so creating like some kind of accessible demo or some kind of like thing that they can really play around with, and maybe that's not going to be the end product, but just like showing them what's possible and then kind of bringing them to like the overall, final fancy solution. But yeah, like we have, so Hugging Face has this thing called Spaces, which essentially you can like drag and drop a model and create like a simple UI around it. And people have really responded to that as being like the most useful thing for them, even like above and beyond any of the LLMs or transformers or whatever. They're like, oh, this is really cool. I have this model. I can play around with it without knowing any code at all. And that's super valuable for them.
So making things accessible goes a long way. And obviously, I think us as technologists and data scientists, we often like to think that, yeah, but I have the answer here, like just take my answer. Whereas I think, Deval, your point is, hey, having someone who really has the credibility in that space, the domain expertise, goes a long way in actually embracing this awesome solution you have versus it sort of sitting in a hard drive somewhere and nobody uses it.
Yeah, not only that, but asking the right questions, right? So that like we may have the answers, but we are answering probably the wrong questions, right? And so domain experts bring in the right questions to answer.
I'll kind of go back to fall in love with the problem, not the solution, right?
Yeah.
So maybe we can change tack a little bit and talk about the impact of all these awesome models we're building themselves, right? So sort of what is the potentially negative risk here? Let's start there before we move forward.
It's really interesting because it's a bit of chicken and egg problem. So actually the biggest models that emit the most carbon, that use the most energy, are like the least useful for climate impacts. And so it's really frustrating because people talk about AI as if it's like one single thing, one single field. And so it's true that, like, I mean, there are all these very small, very efficient models that run. Like, for example, the Rainforest Connections, the one that track deforestation, they use old cell phones and they run AI models on those, right? And they have absolutely like zero emissions. They use solar energy and it's recuperated cell phones. And whereas we have these large transformer models, which, you know, training GPT, whatever, is 500 tons of carbon, and at the end of the day, it's not going to make a dent in climate change. And so I find that it's really frustrating.
ChatGPT won't solve climate change?
Exactly. And also what really irks me about the current like switch to generative AI is that, you know, someone told me recently, oh, like I don't even use a calculator anymore. I just ask ChatGPT, and I'm like, literally the amount of energy you're using to do like arithmetic or percentages or whatever is
everything is a nail when you have a hammer?
Yeah. And that comes with a cost. Like a recent study we looked at open source models because we don't know exactly what's under the hood of ChatGPT, but going from like a specific task model that answers questions based on a text, essentially that extracts answers in a text, versus a generative model that's going to try to answer the question but by generating text, is like 30 times more energy for the exact same answer. Like, what's the capital of France? And then on one hand, you have a model that will just take Paris out of the text, and then on the other hand, you'll have a model that will generate that answer for you. And it's like so much more energy and eventually so much more carbon for something that you don't need a generative model for, right? And so that's what the frustrating bit of this all is for me.
So if generative AI models just kind of keep getting bigger and deployed more and more, are we going to run out of energy?
Well, we have actually a crisis right now. The problem is that the amount of like energy that's required for data centers is outpacing the growth of renewables. And so it's like, potentially in a couple of years, we'll have built up capacity and we can have more renewable energy for data centers, but it's not going to happen like now or 6 months from now. Or
Microsoft is building nuclear power plants.
But that's also going to be a short, like it takes time to build a nuclear reactor. You can't have that, you know, in a couple of months' time. And so we're having like this outpace of data center usage versus capacity, and that delta, that difference, is coming from non-renewable sources.
I think it's going to be like a huge problem with the acceleration of adoption of these models, and I don't necessarily think that the models will get only bigger.
We're just going to use them more.
We're just going to use them more. It's almost like a Jevons paradox, where things will become more efficient, but then because they're more efficient, more people will use that. And so we will still be in this hyper growth, like Jacob, of need for data centers and all of that stuff, right? And so I do think it's a challenge. I was looking at like the California ISO and the Virginia, like the MISO, like, so there is this valley in Virginia where there's some crazy number, like
Data Center Alley.
Yeah, Data Center Valley, right? And so it's basically 40% of the world's like traffic goes through data centers in that, like, say a few, like 10, 20 square kilometer area. And
it's natural gas, I think.
It's natural gas. Now, they don't have capacity, and they're saying we have 200 project long queue for the interconnect. And for people who are less familiar with energy systems, interconnect is a place where you have to actually plug in to get massive energy from. So if I'm going to say build 100 buildings within downtown, then there's one interconnect that I go to and I get to plug in. And the market makers and market takers and the regulatory body needs to decide how that is going to work out, because they need to have the capacity to actually provide that energy. And the capacity is actually not decided by the average. It's decided by 1 minute in past 10 years, which was the highest.
Oh, yeah.
And so that is how you have to define that, right? And so there is no way these data centers are getting built at the rate at which they are building. So on the other hand, I feel like this will hopefully like prompt more innovation in energy efficient computing. And we are seeing some of it. Like we are seeing from all the way from the chip and wafer layer to modeling layer, we are seeing like more and more efficient computing. And at some point that will change. But I do think that when paper like Sasha's paper came out and someone actually asked me a question, you were not there on that panel, and said, oh, there's this paper, and the author basically says that the energy used from computing is going to be a problem, and this was at least more than 5 years ago, I guess, and I said, I don't think so, because guess what, right now the energy consumption from all of like tech sector is less than percentage point, but that has changed. So I stand corrected.
I think data centers are now about 1 to 3% is the ballpark estimate, but it's really hard to get a number, right?
Yeah, 1% in US, and they with this growth rate, they are going to surpass entire aviation industry in next 4 to 5 years, and so there is like a real challenge there.
So like for many of us, we increasingly use generative AI in our life, in our work, we might be sort of building models, training models, aside from like, basically asking ChatGPT less silly questions, right? Like, what are some actionable things we should be mindful of when we're building things, when we're using things, to just be aware of the impact that we may be having? Like, what should we think about? What should we do?
I think the first step is measuring, because a lot of people are like, I don't even know where to start. So if you're either whether it's on premise or in the cloud, there are a lot of, there's several pieces of software that you can use for measuring the energy consumption. So there's one that I helped create that's called Code Carbon. And it's actually like a bit of Python code that will run in parallel to whatever code you're running, and that will give you an estimate of how much energy it's using. And then based on where that code is running, so essentially, maybe taking a step back, depending on how energy is generated, it's going to have different amounts of carbon emissions associated to that energy. And typically, it's never zero. But if it's hydroelectricity, for example, it's going to be very, very low, but there's still like the carbon cost of building the hydroelectric plants. And then if it's coal, it's going to be something like 800 times more, because it's the actual burning of the coal. And so depending on how the energy is generated, that will power your compute. So for example, if you're using US East, Azure or AWS.
What everybody uses?
Exactly. It's in Virginia, and Virginia has mostly natural gas powered energy, so it's going to be something like, 200 or 300 grams of carbon per kilowatt hour. And if you're using a data center in Quebec, it's going to be something like 20. And if you're using a data center in Singapore or Australia, it's going to be like 800 grams of CO2 per kilowatt hour. And so Code Carbon essentially has this information and will give you a little estimate at the end of the code how much energy and carbon you used. And I think that's starting from there and being like, okay, well, can I maybe simplify some processes? Can I switch my compute to another region? Sometimes it's possible, hopefully. Like that's what I did. The first thing when I arrived at Hugging Face, I was like, US West. Everything is going to US West. So now it's all in Oregon, which is mostly hydro. But anyways, like changing small things like that and like thinking about like tracking that essentially across time is a good place to start.
Honestly, that's something I'd never considered, right? Like a lot of our customers' compute is in US East.
40%.
And just sort of moving that over, right, has a massive impact.
And there's also this concept of additivity. Additivity. And so the idea is like, well, the more renewable energy you want, like people want, customers want, utilities will kind of follow up. Yeah, it's like market demand. But it's like really the fact that we can have, like with things that we plug into a socket in Toronto, we don't really control where that energy is coming from. But with compute, we do to a certain extent. Now, of course, like there's not always GPUs, blah, blah. But I mean, we do have more market power than for local energy usage. And I think that's something powerful that we can control as an industry.
That's a great insight.
There's like a really good nonprofit, like What Time, and they do a brilliant job at just tracking like where this energy, so what's the carbon intensity of like every single node.
And they're collaborating with Google Cloud, right?
Yeah,
like they recently.
Yeah. So I think there are now tools out there, right? But I'll say like we have to apply the same concepts that you would apply to say day-to-day living sustainability, right? Say it's about say rethink why you need that. Like going back to like what Sasha was saying, like I said, do I even need to use generative AI for this? Like it's the first question we should ask. Like I say, do I need this item or not? Like recycle is the last step in all of sustainability, right? And so
convincing customers is harder than convincing us, right?
Yeah.
Like they want generative AI. Like that's kind of the badge of honor.
I don't think so. The thing is, like, I was just telling someone that one of the founders, I'm having like a bunch of conversations with, brilliant founder, and the person said, like, all of this, like, say, FOMO of using generative AI is now turning into FOMO, which is like fear of messing up. and so I think we have an opportunity where we are now starting to find limitations of what this technology can and cannot do. And thankfully, or not so thankfully, one of that limitations is actually cost. Like, and so hopefully that will also mean that we will, rather than say using, say, ChatGPT for every single, or Anthropic, I don't want to pick on like one kind of a company, but rather than using these large foundation models, can I host my own models? Can I do this with a simple regression model? Can I just build a better graph-based search? And so all of those things should be considered, right?
I would imagine that local models that are running on my device are likely much better from a sustainability perspective than the ones in the cloud.
Well, it depends on where the energy is coming from, but yeah. The thing is also, like, I think that foundation models are appealing because they are supposed to be doing everything, but it's quite rare in practice that you need an AI system to do everything.
100%.
Like when I was working in an industry, it was like, you don't need like generating images and answering questions and whatever else, right? Like sometimes, like mostly it's like, okay, you need this specific thing, and then fine-tuned or task-specific models do a great job at that.
Just to sort of, plug your example of, hey, what do you do in your real life, right? Sort of, hopefully everyone will bike home today, But with that in mind, maybe why don't I ask the two of you to just maybe take 15, 20 seconds and give us your key sort of takeaways about how we should be thinking about things, and then maybe we'll open it up to questions.
Maybe I'll start. So I think at least what has helped me is we have to move beyond this concept of like carbon footprint and think about like this concept which I really like as carbon shadow, and which is like saying it's not just about where we leave our footprint, it's about this shadow which follows us continuously, which is more holistic, right? And so it considers externalities. It's also about, say, it's a continuous process, and it's not just say one thing that happens in a set time and then leaves. And it considers both in terms of, say, what's the positive side of this technology and also what's the negative side of this technology. And so I think rather than thinking of it in, say, one, and a fun fact, like this whole idea or even the term like carbon footprint was coined by BP as an ad campaign.
To shame people.
It's about like shifting responsibility to consumers, right, kind of thing. And so we have to think more holistically than just say, okay, this is what the energy or the carbon footprint is. Yeah,
and to add on top of that, I think that once again, as consumers, as developers, we have a lot more power than we think we do. And if we start like collectively asking for more transparency, asking for more information, choosing, not to use a tool unless we know like, how much energy it's using or where it's running or the bias or whatever. Like, I think that we do have this, like people essentially don't think that they have an option or they have an alternative, but they do. AI is a very distributed field, and that's actually what's great about it. It's like, I mean, you kind of you focus on a couple of companies and sometimes you demonize them and some people worship them, but at the end of the day, you have a lot of choices, and I think that's a great part of AI, and I would love it for us to be a little bit less kind of obsessed or monopolized by a single few companies and have more like, diversity, more like building upon, small startups and scale ups and things like that.
That's the perfect way to end this. Question.
You just described the project that I'm currently working on. I'm working to develop Energy Star ratings for AI models, and so the concept of Energy Star came in like the 50s and 60s, where it was for appliances, and so essentially for a washing machine or a computer, you would compare the energy consumption and you would say, well, this is more efficient, this is less efficient. And so we're trying to do something similar with AI. The thing is that there's a lot of different tasks. So, it's not like a one-size-fits-all. It's not like just like a washing machiner. And so we defined 10 tasks, and we're benchmarking models on data sets for those 10 tasks, and then we're essentially establishing a range. And so we've already tested most of the models on Hugging Face, and now the challenge is trying to get closed source models tested. And so I think I'm going to spend my summer trying to convince OpenAI and Microsoft and whatnot and Google to test their models, because essentially we wrote the code. You can run it internally and then give us the numbers. The thing is, with showing people the results, we will, but the thing is, at the end of the day, every time I do research on open source models, people are like, well, what about ChatGPT, right? Like we did the study on inference, and then, it's like we compared answering a question versus like generative versus extractive, and then they're like, well, how does that compare to ChatGPT? And you don't know at the end of the day. And that's what's really frustrating, because the most popular tools are closed source tools. And so it's like you feel like you're done half of the job because you can't give people the numbers. And so hopefully getting people on board and having a more holistic approach. And
What a brilliant idea, and we wish you luck.
thank you.
Maybe one last question?
So traditional models require a lot of clean data, right? Not clean data, maybe a little bit unclean data, but it requires data. So if you are trying to identify stuff like greenwashing or transparency in big tech or financial corporations, then you need that kind of data wherever. However, if you are using NLP and this open source model, you can generate you can get this their sustainability reports, climate reports, all other articles that are free source data sets for us. It's easier for these models, this GPT models and BERT models to be used there more. So for us to get back to that level of traditional model, like use causal inference and stuff like that, to address climate change, don't we need a little bit of more data sets which should be a little bit open source and not so close, basically the company's data sets or numbers, what kind of emissions they are doing and stuff like that?
So if I understand the question correctly, I think I'll just try to rephrase the question here. Is say the question from what I think you're trying to ask here is, don't we need more open source data sets so that we can scrutinize the information better?
Yes.
Yeah, absolutely. I think across the board, like having access to the right data sets and aggregated data sets is tough. It's probably one of the big, I don't think applying AI in energy transition or climate, the problem is not the algorithmic space, the problem is the data space actually. Like we just don't have that.
Yeah,
Yes,
I mean, so I sit on the board of Cycle Toronto here, and we don't have data about cycling in Toronto. Like there's just no data for it. Like even
They
just
have like sensors in Montreal. They're great. They count the number of cyclists that go by.
we haven't made it this far yet. Right? But like even we don't need to do that, right? Like most cyclists have phones, and there's like there are ways for us to get
Project
this data.
Sidewalk was so promising. We didn't talk about ethics, guys.
I know.
Like I think the data piece is huge here for sure. Deo?
Yeah, I mean, but also I think there's a role for like consortiums, right? And I think there's something, what we have to do, what I learned from say, the for-profit side of this whole equation is, you need to create like mutual value, right? And say like if you're going for, we can increase efficiency of your X, Y, and Z, give us your data. I think that is less valuable. But you can say, okay, we can pool data from all of you. And now guess what? Like every time there's like a new startup, there's a new company telling me that it increase efficiency, but they have zero access to our data. Why don't we create an open source data set? Maybe it's like 1% of the real world data, right? And then that creates a mutual value, right? So you have to create like win-win situations. Yeah, incentives for profit. Like that's how, like it or not, we didn't talk about ethics. That's how the world works.
Capitalism. Sad note to end on.
Maybe we'll end on something good. Open is good, right? So sort of better data.
Yeah, I see Hugging Face as a platform for like recycling, essentially. Like that's why I joined Hugging Face, because it's like instead of like training a model from scratch or building a data set from scratch, you can get someone's and maybe
100%.
adapt it or. Yeah.
100%.
I would say though, I think at least at this point, the incentives of capital deployment and energy transition and climate are actually aligning very much. And so I think everyone is rallying behind it. And hopefully then the job for all of us here is directing that capital to the most impactful problems.
Vote with what we use, right? Sort of vote with our money, vote with our API usage. Use Hugging Face.
Build your own model. Build your own model.
There's a question there.
It's a nice discussion. Thank you for that. My question is, say, foundation models is mainly in English now, right? What will happen if the whole world, especially Chinese and Indian markets, start creating foundation models and RAGs in their own native languages?
They do.
Yeah, they already are doing that.
Not in this scale like in English, right? When it catches up like wildfire, how will the sustainability and the power consumption, how this is going to work?
This is something we should have talked about. Essentially, there's always going to be a tension between sustainability and ethics and justice and representativity. And the thing is that there's no real answer to these questions, but I think it's important to start at least like insisting, for example, if people start emphasizing, the thing is, there's more English models, not as such because of English countries, but because of the internet that has a lot of English data. So essentially curating smaller data sets in languages and training smaller models is like a win-win for like representativity and for carbon. So it's often actually linked, and like these big models are neither very good in representativity nor very good in terms of like carbon. And so like trying to make connecting these dots is essentially a good place to start.
And I would just add, say, from the energy transition perspective, I know we are over time, but I'll just say this, like from an energy transition perspective, the examples that you gave, like India, China met their climate goals 14 years in advance for solar and 7 years in advance for the entirety, the blanket climate goals. They're going to meet it like this year instead of like 2031. So I think they're doing more in terms of transitioning their economy. And so hopefully, and in general, even if they don't transition, the energy intensity, carbon intensity of the energy systems in the global south is much orders of magnitude lower than US or Canada or Europe. And so I wouldn't say I'm too worried about, like, say, global south catching up on technology and building their own models and stuff like that.
Thank you, everyone.
Thank you.
Thank you to our panelists.